So let's go back to tables of data. You'll have seen these a million times at GCSE, and some of these calculations you will have done before. So we're going to talk about the mean to start with. This will probably be revision, but if you can't remember, don't worry, we're going to go over it. So first of all, a bit of notation. X with a bar on top means the mean of X. Okay, so X is a load of data points. X with a bar on top means the mean of all those data points. And here I'm showing you how to calculate the mean when we've just got a list of data points. So say, for instance, I had a list of points, let's say 5, 8, and let's say 14. So these are all my X values, and I want to find X bar, which is the mean. Now, if you look at the formula, it says we'll do the sum. So this notation here, it's called a sigma, and it means sum all the x's together. So all of our x values, our 5, our 8, and our 14, we're going to add them all together. So the sum of x is 5 plus 8 plus 14. And then I'm going to divide by n. Now n, so I'll just write down some stuff here just for your benefit. So this is the sum of all the x values. And n is the number of values. So in our case, n is 3, because we've got 3 different points, the 5, the 8, and the 14. So this is the normal way of working out the mean. We add everything together and divide by the amount of numbers, okay? So this is just kind of a fancy notation for probably the way you've always worked out the mean. If we do 5 plus 8 plus 14, we get 27, divide by 3, we get 9. So the mean of those 3 numbers is 9, okay? So it's fairly straightforward when we just have a list of numbers. We just add them all together and divide it by how many numbers there are. We've got a slightly more complicated formula when we've got data with a frequency column. You will probably have seen this at GCSE. They look something like this. Okay, so this is an example of height. We've measured a number of people and we put them into categories. Instead of just measuring their exact height, we've measured it and said, well, they're in the 150 centimeters to 160 centimeters category. So we're saying there's 6 people who have a height between 150 and 160 centimeters, and there's 12 people that have got a height between 160 and 170 centimeters. We need to be able to find the mean from sets of data like this as well, or more accurately, I should say, we need to be able to estimate the mean. The truth is we can't exactly find the mean because I don't know how tall the people in this group are. I just know they're between 150 and 160, so it is a bit of an estimate really, but we need to be able to do that. These last columns, so this is the midpoint that we're looking at here. You'll probably have done this before. The midpoint is just the middle of this category. So in the 150 to 160 category, the middle is obviously 155, okay? What we're really doing here is we're saying, well, we're going to pretend that everyone in this category has got a height of 155 centimeters. It's an estimate, but it's a fairly good one because we can assume that they're all kind of in the middle. Now, if we have a look at the formula up here, we want to do the sum of fx. Now, f is the frequency, this column here. X is the midpoint, so these are our x values here. So we're going to multiply the two numbers together, and then after that we're going to sum them all together. So this fx column that I've got is just the frequency multiplied by the midpoint. So I've done 6 times 155, and I've got 930. I've already worked out all of those for us instead of working through them all. Now, this n here is again the number of values, or the number of people I've measured the height of. To get that, I sum all the frequencies together, okay? Because I've measured 6 people in this category, 12 people in this category, 15 people in this category. So if I sum them all together, I'll find out how many people I measured the height of, and there's 51 people. For the top of that formula, I have to do the sum of fx. So that's of that fx column, I'm going to sum all those numbers together. So all of these I'm adding together. So I've done 930 plus 1980 and so on and so on. I've got 8885. And now we just apply the formula. It says do the sum of fx, which is 8885, divided by n, which is that 51 figure. And there you go, there's the mean height, 174.2 centimeters. We can always check that sounds about right by looking at the data. So 174 is in this middle category, so it seems about right. We've got somewhere in the middle, which is what we expect for the mean. So it seems to make sense. If I got 130 centimeters as the mean, it's clearly wrong because no one's actually that short. Or if I got 250 centimeters as the mean, again, it must be wrong because no one's that tall. So we can always sanity check those values, and it's a good thing to do. It means you can tell straight away whether you've got something that could be the right answer. Okay, so they're the two ways of finding the mean. Really easy when we've just got a list of numbers. A bit more difficult when we've got a frequency as well. For most of you, I think you'll have done this frequency calculation before to get the mean. But please do have a look over it if you're not sure, because it could well come up on the exams. Even though it's really GCSE content, it may still come up as like a part A or a part B to a question. We'll have a look at the median now. This will be a little bit new, and this is where we have to remind ourselves what the difference between the mean and the median actually is. The median is the middle person. So that's what we saw on the box and whisker plots before. The mean is more of a kind of, well, it's an average just like the median is, but we get the mean by adding everything together and then dividing by how many things there are. The median is, if we line everything up in order, it's the middle item of data if we line everything up. Okay, so they sound kind of similar, and they often are, but they can be different. Okay, and in tables of data, they do tend to be slightly different. So how do we find the median? We use the formula n+1/2 to find where the middle person actually is. Okay, so remember, n is the total number of people. Now you might be saying, well, why isn't it just n divided by 2? That should give us the middle person, shouldn't it? Well, think about this. If I had 5 items of data, where's the middle person in this list? Well, it's the 9, isn't it? The 9 is the middle person. Okay? But if I've got 5 items of data, and I just did 5 divided by 2, I would get 2.5. Okay, now 2.5 is here somewhere, isn't it? It's between the second and the third value. So that's not right. It should be 3. Okay, so what I have to do is I have to do the n, which is the number of data points. I have to add 1 onto it and then divide it by 2. That gives me 3, which is what I want, that third person, which is in the middle. Okay, so it's not quite as simple as just dividing by 2. I have to apply this formula. I have to add 1 on and then divide by 2. Now that could mean I get something 0.5 as a number. That's fine. Say I had 4 pieces of data. The middle point is actually between those two, isn't it? It's between the 4 and the 7. And that's okay. So it would be the 2.5 person, the 2.5 person who's in the middle. That's fine. We can deal with that, okay? But use this formula to figure out where the middle person is. It's not as easy as just dividing by 2. We need to add 1 and then divide by 2. Right. I'll go through this in a second, this linear interpolation thing. This will be new, no doubt. This doesn't crop up in GCSE normally. Okay, this tells us how to actually find the middle person in a table of data, and I'll do an example to show you. So I've just stolen that height data from the previous section when we talked about the mean, and we're going to have a look at how we find the median. First of all, we need to know how many people there are in this group. So there's 6 in the first group, 12 in the second, 15 in the third, 16 in the fourth, and 2 in the last one. That's 51 people overall. Okay, that's n. Remember, the n is the total number of people or the total number of items. If it's because it's not always people. So there's 51 overall. Now, if we apply our formula, so we're going to apply this formula here to find the middle person. So the middle person is 51. We add 1 on. Then we divide by 2. That's 52 over 2, which is 26. So we're looking for the 26th person. Okay. So what we're going to do is have a look in our table of data and try and think about where the 26th person is. Well, if I go down this group, there's 6 people in here. There's a further 12 people in here. So I'm up to 18 so far. This is like my cumulative frequency, if you like. 6 people, and I'm up to 18 people that I've gone past. Because these are all in order, effectively, aren't they? So I'm looking for the middle person. I'm 18 people through. So it's somewhere in this group. Because after this group, I'm up to 33 people that I've looked at. So the middle person is somewhere in between here. So So the middle person is in this group somewhere. Okay, and we're trying to figure out, or come up with an estimate, I should say, as to where that middle person is. Okay, we don't know the exact height of the people in this group. Okay, so we're going to have to make a bit of an estimate. This is what linear interpolation is for, this linear interpolation method. So it's 18 people to get to the start of this 170 to the 180 group, and there's 33 people by the end of the group. There's 15 people inside the group. So what we're going to do is this, to try and apply this formula to find out where this person is. So it says start of the group. The start of the group is at 170 centimeters. Okay, it goes between 170 and 180. The start of it's at 170. And then it says add on how far through the group we need to go. Now we're 18 through already, and we're trying to find the 26th person. So we have to go 8 people into this group to find the 26th person. We've got 18 people already. I need another 8 to get to the middle person. So I'm going 8 people through this group. I'm going to divide that by how big the group is overall. So the group is 15 people overall. So if you like, I want to go 8/15ths of the way through this group. I want to go 8 people through the 15 people who are in this group. And I'm going to multiply it by how wide that group is. And by how wide, I mean, look at the class boundaries here. The group's 10 people wide, so I'm going to multiply by 10. If I apply that formula, I'm going to type that in now and find out where our middle person is. I get 175.3 centimeters. Okay? It seems like a reasonable estimate, doesn't it? Because it's somewhere in this group. 175 centimeters is in this third group, and it's somewhere near the middle, which makes sense because we wanted to go 8 people through the group out of a total of 15, which is about half, isn't it? 8 out of 15. So I end up with that. Now, if you remember from the previous bit about the mean, I think we got 174 point something centimeters for the mean. So you can see it's very close, but it's not exactly the same. And that's often true of the mean and the median. They're close, but they're different, and they tell us slightly different things. Okay, so that's one example of how we calculate the median. I'm going to do another example now with just a slightly different set of data, just to get you an idea, because I know this isn't very straightforward and it can be quite difficult to explain. Please be aware as well that there is more than one way to show how linear interpolation works. If in class you might have done it with sort of 2 lines and then working out what proportion you need to go through, that's fine as well. If you've got a method that works for you and you consistently get the right answer, that's fine. I'm just showing you a way that I think works quite well, and it kind of explains how linear interpolation actually works. So instead of looking at height, we're now looking at wait times. So this might be, I don't know, how long we wait for a train or something like that. And again, we're going to try and apply this formula. First things first, we need to know n. We need to know how many people we surveyed overall, how many people we've looked at. So if we add all these up, we get 30. Now the middle person, we apply the formula. So it says do n plus 1 over 2. So that's 30 plus 1 over 2. And that actually gives us 15.5. So I want the 15.5 person, which sounds quite weird. We can't have half a person, but we can when we're doing the median. Okay, it's just an estimate. We want the kind of the in between the 15th and the 16th person. So now we try and apply our linear interpolation formula. So if we have a look, we want the start of the group. First of all, we need to figure out which group we're actually in. Well, there's 12 people in this first group. Now, by the end of the second group, we've had 22 people. Okay. So I'm past the median at that point. So we know the median must be in this group somewhere. Okay, it's partway through this group. So if it's in this group, the start of that group is 2. Yeah, the start of that group was a wait time of 2 minutes. I want to add on how far through the group I want to go. By the time I enter that group, I've already had 12 people. If we imagine all these people lined up in order, I've already seen 12 people by the time I get to a wait time of 2 minutes. So I only want to go another 3.5 people through the group. That takes me to the 15.5th person. Yeah, 12 plus 3.5 more people takes me to the middle. I then want to divide it by the total items in the group, or how many things there were in the whole group. So there's 10 people in the group, and I only want to go 3.5 people through. I want to go 3.5 of the way through the group. And then I'm going to multiply it by how wide that group is. So the width of the group is from 2 to 5, so the width is 3. And if I type that in, I'll get an estimate for our median. So I get 3.05 as our estimate, or 3.5 minutes. 3.05 minutes, sorry, which is 3 minutes and a few seconds, 3 minutes and 3 seconds. Okay, so that's another example of how we get the median. Okay, try and apply this formula. I think it's quite good because it explains how linear interpolation works, how we're going a fraction of the way through the group. If you have another way that already works for you, that's absolutely fine. Please keep applying that. The important bit is finding the middle person as well. Remember to add that 1 on and then divide by 2. Again, there's multiple ways of expressing this rule as well. I've gone for what I think is the simplest. There are some other ways of doing it which you might have been shown, but you should get very, very similar answers. Let's have a look at those quartiles again now, which we started with right at the start. Just like we can find the median in a table of data, we can also find the quartiles. So we want to find the person who's a quarter of the way through the group, or 3/4 of the way through the whole data. And there's a little bit more complicated to work this out. And again, you might have been shown different ways of doing that. That's not really a problem. This is just, I think, the most accurate way of doing it. Just like we did n plus 1 over 2 to get the middle person, now we're doing n plus 1 over 4 for the quartile. For the upper quartile, Q3, we're doing 3/4 of n plus 1 over 4 and multiply by 3. Okay, so they're the two ways of finding the quartiles. Again, we're going to use our linear interpolation formula to find an estimate of where the person is in that group. That formula is not changed, it's exactly the same for the quartiles and for the median. So let's have a look at that wait time graph again, and this time we'll find the lower quartile and the upper quartile. Again, remember this is just an estimate, but we need to be able to do it for the exam. So let's start with Q1. We want to find the person who's a quarter of the way through the data, so I do n plus 1 over 4. Remember there were 30 people here total, so I do 31, oh sorry, that's 30 plus 1 over 4. That gives me, I want the 7 3/4 person. Again, this sounds very strange, but it's fine. We can just do an interpolation to find it. It's between the 7th and 8th person and closer to the 8th person we're trying to find. I'll try and apply our linear interpolation formula now. Now the 7.75 person is in this first group because the first group's got 12 people in. Okay, so Q1 is in this group. Now the start of that group is at 0 minutes. I'm going to apply the formula now. Start of group is 0 minutes. I want to add on how far through the group we want to go. So I want to go 7.75 people through the group. The total items in the group, or the total number of people in that group, which was 12. And multiply that by how wide the group was, and it's gone from 0 to 2 minutes. So it's got a width of 2 minutes. If I apply that formula, I get 1.29 minutes. So that's an estimate of Q1. Okay. For Q3, the upper quartile, I'm going to apply this second formula here. So I'm going to do 30 plus 1 in brackets and multiply that by 3/4. That gives me 23.25, so that's the person I want. So I want somewhere between, if I imagine all these people lined up, I want somewhere in between the 23rd and the 24th person, and slightly closer to the 23rd person. If I have a look down here, so there's 22, I've been past 22 people by the end of this group, so I know that the 23.25th person is in this third group. So we apply the linear interpolation formula. In that third group, the start of the group is 5 minutes. I add on how far through the group I want to go. I'm already 22 people through when get to the third group, and I want 23.25. So I need to go another 1.25 people through. I divide that by how many people there are in that group, which is there's 5 people in that group, and then multiply by how wide that group is. It's all the way from 5 to 10, so it's got a width of 5 minutes. And I shove all that in the calculator. And we get 6.25 minutes. And that's my estimate of Q3. Okay, so that's 6.25 minutes, or 6 minutes 15 seconds. And that's our estimate of the 2 quartiles. Now from that we can also work out the interquartile range if we wanted to as well. All we do is subtract Q1 from Q3. That's dead easy to do. Okay, so this bit might seem a little complicated, but after a few practice goes, which you can do with the practice questions on Solve4x if you like, we've got lots of questions there for you to have a go at. I think you'll find this isn't too bad. As I say, there's multiple ways of finding the quarter of the way through and 3/4 of the way through. If your teacher's showing you a different way, just continue to use that. That's okay. It's the same with the linear interpolation. There's a couple of ways of doing it really, which should give the same answer really. Just slightly different explanations of how you go about it.